Hello, everyone. Testing, making sure I'm live. I know last time I did a workshop, my audio turned off at the beginning. So if anyone's already here, actually, it looks like quite a few people already are here. If you want to let me know in the chat real quick that you can hear me and see the screen, it's always good for me to double check. And we'll get started here in just a couple minutes. We're going to wait for some more people to join in. While we're waiting, again, let me know in the chat a little bit about yourself. It's fun to kind of hear about the audience, maybe what you're working on, why you're interested in machine learning monitoring. Are you working on an interesting machine learning project, whether that's for school or work? Let me know in the chat. And I'm going to make sure that the stream is going everywhere. Looks good. Again, if someone wants to let me know in the chat that you can hear me, that'd be great. Looks like my audio is working. How was everyone's day so far? Someone said they're looking forward to understand the topic of bias and explainability. Awesome. Someone said, yes, they can hear me, or a couple people said that. Thank you. Thank you for letting me know. Just wanted to confirm. And all right, we're going to wait just a couple minutes to get going. But while we're waiting, I'll also share a couple links for setup if you want to follow along with everything we're going to be doing today. And I'll talk more about setup in a little bit as well. But we're going to go through just a little bit of slides first, just to kind of catch people up on some of the terminology and what we'll be doing today. And then most of this is going to be hands-on. So if you want to follow along for all the hands-on portion, really probably the only thing that you don't have already maybe is a YLabs account. You can sign up for free. The link is in the description. All the links for everything that you're gonna need today is in the description on YouTube. And I'll share these over in the LinkedIn stream as well. But the main thing for setup is you probably just want to create a YLabs account. It's free. There's no card or anything required. You just have to verify your email, and then you're going to be good to go. And then we'll be using a Collab notebook. And again, you don't have to copy all of these right this second. I'll go over them again as more people join in and when we get to the actual hands-on piece. And then we're going to be using an open source library today called YLogs that we maintain. I'll share access to that GitHub repo. And if you have a GitHub account, we always appreciate a star as well. And then also important, if you want to stay connected after this workshop, ask questions about ML monitoring or just anything about your project, feel free to ask us in the Slack channel. It looks like one of the links didn't share. I'll share YLogs again. And again, we'll get going here in just a couple minutes. I'm going to wait for some more people to roll in. And while people are joining, if you just came in, let us know a little bit about yourself in the chat. Maybe what you're working on, why you're interested in ML monitoring. Have you ever done any ML monitoring before? Or put a model in production, I think is actually a good question. And I'll share one more link here as well. If you're interested or you're working with large language models, we are launching a new project around that very soon. And if you want to sign up and get early access to it, you can do so there. Someone said, no, not yet. I assume that's to putting a machine learning model in production. Well, it's going to be fun when you do. There's always a lot to learn. If you haven't put a ML model in production yet, but maybe you've trained a model in a notebook or anything like that, and you haven't really gotten to the world of MLOps yet or putting things in production, training the model is always just kind of the tip of the iceberg a little bit. You'll think you're done until you actually want to do something with it. You have to, put it out in production somewhere so the world can interact with it. That's usually how you get a lot of value from it. And things go wrong or things happen to your model or data, and those are things we'll be talking about today. So I'll just wait one more minute, I think, before we get going in the slides. I shared the links in the YouTube chat. So again, if you want to go ahead and just create the YLabs account, that's probably the only thing you don't have already. We're going to use a Google Colab notebook for the hands-on part. So that will require a Google account. I'm guessing that most people already have a Google account. and you won't have to create one. So I'm going to share just this link as well for the LinkedIn stream real quick, and then we'll go ahead and get going. And again, for everyone who just joined, feel free to introduce yourself in the chat. Tell us a little bit about maybe projects you're working on, why you're interested in ML monitoring or machine learning in general. That would be great. Get this link one more time. And also in the LinkedIn stream, I'll share the link to the YouTube stream as well. And all the links that I just shared are in the YouTube description. So if you want to get to everything, go to the description if you don't have them already. All right, so I know people are still going to be rolling in, but we'll go ahead and get going in the slides. And I'll tell you a little bit about the workshop while people are rolling in. So what this workshop is, hopefully it's a super friendly introduction to ML monitoring, kind of designed with no previous experience expected, but definitely knowing some Python and machine learning concepts will be helpful. But we'll cover high-level concepts around ML monitoring and then do a lot of hands-on part. And even if you've never done machine learning before, or not a lot, you'll still be able to run all the code, and I'll kind of explain what's happening. So depending on your level of knowledge around machine learning, this could feel fast-paced and challenging, but that's totally okay. I know that's kind of how I like to learn, is dive deep in. So again, even if you're pretty new to ML, you can still follow along with this workshop. So don't worry about having like prerequisite knowledge or anything like that. We'll kind of cover high level concepts and then go in and do hands-on. A quick part about the agenda. So we're going to do the quick intro like we're doing right now, and agenda. And then we're going to cover just some concepts and slides. It won't be that long. And then we'll go and quickly go to the hands-on workshop part. So again, we'll be writing stuff in a Collab notebook. There won't be a lot of setup for you to do to follow along. And I just want to clarify that you'll be able to learn a lot just by sticking around for the first hour or so, 45 minutes, depending on how many questions we get. And we're going to cover all that kind of in that first hour. So you'll be able to learn how to set up ML monitoring, detect data drift, look at your model outputs and performance. And then we'll go into a little bit more advanced topics later. So if you do have to drop off early, I would just suggest sticking around at least for that first hour. And then we'll go into the other stuff. And a quick introduction about me. I'm Sage Elliott. I'm a machine learning and MLOps evangelist at YLabs. We create tools around ML monitoring, AI observability, and data observability to make your ML models and AI applications more robust and responsible. So, making sure that you catch things that go wrong very quickly. And also, again, we'll be talking about things today like bias a little bit in your model. So once your model's in production, making sure that you're running that responsibly. For over the last decade, I've worked in software or machine learning or hardware, mostly with startups and some small agencies around Seattle and Central Florida, where I lived before hopping over to Seattle. And I love making things with technology. And as a hobby, I like biking, but I also like doing kind of robotics. So if anyone's interested in robotics stuff, feel free to connect with me on LinkedIn. You can find me as Sage Elliott. I think the link might be somewhere in the Collab notebook later as well. But I'm always happy to connect with people and talk with people. And I'm also in that Slack channel I shared earlier. So if you just want to ping me about robots or machine learning, that's going to be a good place to do so. So about you. So I saw a lot more people join since we started going. At a bare minimum, maybe put in the chat, where are you watching from? I think that's always fun to see kind of where everyone is watching from right now. And if you want to add a little bit more, mention again why you're interested in ML monitoring, or maybe just machine learning. So maybe you don't really even know exactly what ML monitoring is right now, but you're building something with machine learning. Go ahead and throw that in the chat. I think it's really fun, not only for me presenting, but everyone else here too, to see kind of where everyone's coming from and what maybe you're working on. And again, I'll share this link one more time in the chat, and the link is in the description below. But I definitely recommend joining the Slack channel. And there's an introduction channel there as well. So if you want your intro to be a little bit more permanent and stay connected with fellow practitioners, that's going to be a good place to do it. And if you have any questions about what we cover here today, as you're putting it in your own project or anything like that, you can connect with me there and the rest of the YLabs team. People are watching from all over: Australia, New Zealand, Michigan, Sammamish. Someone's from Seattle, Washington. And I think I said I've worked in Seattle. I am in Seattle now, too. Seattle is great right now. The weather is pretty great. It just cooled off, but it was really sunny. Watching from Orange County, California. welcome. I love seeing like where everyone tunes in from. It's really fun and exciting. And one of the reasons why it is cool to do virtual events still. So I love doing stuff in person, but doing virtual stuff and be able to meet people that are all the way in New Zealand, for example, is awesome. Someone else is in Seattle. Very cool. And I'm also excited. A lot of in-person stuff is starting to pop back up. So I probably will be doing in-person events and maybe workshops and stuff around Seattle and maybe San Francisco as well. Has anyone gone to any fun in-person stuff recently? Someone said hello from New York. New York seems like they're having a lot of cool events around AI and machine learning right now as well. Someone said Vancouver. Vancouver, Washington, or Vancouver, BC? Either is nice. All right, I'll keep going, but please feel free to keep posting in the chat. Quick setup again. So I know a lot of people just joined in. The only thing you'll probably really need to take a few minutes before we get to the hands-on part to do is create the YLabs account. Again, it's in the description. I'll share the link here again. There's no card or anything required. You just put in your email, you verify your email, and then you're going to be good to go. And then you'll also need a Google account because we will be using Google Colab to run everything in. And Google Colab is kind of Google's way of hosting a Jupyter notebook where we can run code and look at visualizations and outputs all in one place. We're going to use scikit-learn to train a model. And again, don't worry if you don't really have experience with machine learning. You'll still be able to run all the code, train a model, scikit-learn. And if it's your first time training a machine learning model, that's awesome. Then we're going to be using the open source library called YLogs, which is a library we maintain to collect AI and data telemetry. Then we'll use the YLabs platform to easily take that telemetry that we're going to collect, and we'll talk more about this a little bit later, and then be able to monitor that over time for any issues that might pop up in our machine learning pipeline. And we'll use SHAP a little bit, which is a open source library as well for model explainability. We'll actually be able to take a look at our model, understand a little bit about the features that are the most important to making the predictions there. And we can kind of tie that all together with all the other stuff that we're going to learn about. Someone said they're an economist and they want to move in the AI ML space. That's an awesome background, I feel like, to have as well, actually, from economy. And I used to work at a programming boot camp for data scientists, and actually a fair amount of people that would come in with like an economy background did super well in it. So awesome experience to bring in as a data scientist, I feel like. All right, so continuing on with the slides, and for the chunk of people that came in a little bit later, I was just mentioning we're just going to go through a little bit of slides, catch everyone up on some theory and concepts, and then this will mostly be a hands-on workshop where we can go ahead and run code, look at output, and I'll encourage you to play around with the stuff. All right, so what is ML monitoring? At a high level, this is kind of what the system architecture could look like. Someone, is this the chat for this presentation? Yes, I'll be checking the chat. Again, if there's a lot of chatter in there, I might not be able to get to all the questions or anything. But yeah, this is where we're going. All right, so at a high level, you'll have an architecture something like this, where you have your pipeline. So this would be where you're running a machine learning model. You might be doing transforms on your data and making predictions. And then we're going to be using, in this case, YLogs to collect some telemetry. And YLogs does this in a privacy-preserving way where we just collect summary statistics about your data set. So no raw data actually leaves your system in this case. So this kind of lives in the pipeline over here. And then we're going to take those profiles of the data, those summary statistics of your data, and then send them to a platform, in this case, YLabs. And then with that, we can visualize those over time. We can, forecast what might be going on with our data. We can detect anomalies in our input data or model outputs, and we can set up monitors so we don't have to manually go in and look at these visualizations. We can just get alerted when something happens. And then also we can debug our models in production, again, for things like we'll talk about in a second, like data drift, but also for bias. So if you're running a model in production, you want to see how it's performing on certain subset of your data, that can be a good way to do it. And also, this is really usually a very important part of your MLOps loop. So again, if you've never put a model in production, typically you're going to be deploying a model. It's going to be making predictions on data coming in from some sort of source. And then you're going to want to usually build in some sort of loop that makes it very easy for you to take that new data from production, probably annotate it, especially new variations that it's never seen before that it might not be performing as well on, then retrain a model with that new data, and then deploy that new version of the model. And so you want to be kind of monitoring for this over time. So you deploy a model, monitor data coming in. Someone said, can they shrink or remove the video window? Let me see. Is this better for everyone? In a little bit, we'll get to the code, and then that will be zoomed in as well. Also, you can potentially try making it full screen if you haven't already on YouTube. All right, so let's go a little bit more into why we need ML monitoring. So again, put in the chat if you've ever put machine learning model in production, and maybe you've experienced some of these, and we'll go a little bit deeper in a second as well. But when you deploy a machine learning model, like we were talking about, things usually happen to your data or model predictions. Things like data drift can occur where the input data to your model no longer really matches the training distribution that was in your training data set. So chances are your model's probably not going to be giving the most accurate results on that new data. Data quality, again, we'll go deeper into some of these, but data quality could be self-explanatory, but that could be where the data no longer is the quality you expect it, and that could be something like, maybe you should never have a negative value in your data set or a 0, and somebody entered it wrong somewhere. A schema could change anywhere in your pipeline, and that could cause some sort of issue. You have concept drift. Again, we'll go deeper in this, but that's kind of where the model grew a little stale and maybe is no longer mapping to the correct predictions. And then you have things like you might have probably looked at accuracy or recall or things like that, even if you've never deployed a model. But you might want to be measuring these things probably over time, because even though your model might have had like a 90% accuracy on your evaluation data set, then you'll want to see over time, is your model maintaining accuracy. And then bias and fairness, you might want to segment your data in certain ways when your model's making predictions to make sure that it's not being incredibly biased towards a certain class of data. A common example of that could be credit card approvals for a gender or something like that. So just diving a little bit deeper into quality examples, and put in the chat as well if you've experienced a data quality issue. And this might have been with a model in production, but it could have also been a model during training or just in the evaluation. So some common examples of this could be external changes, like the input data or the input sensor is damaged, causing bad data. So if you're doing something like computer vision, that could be a camera. You might be collecting some sort of telemetry from IoT devices or temperature or something like that, and your sensor can go bad and cause the data to look very wonky. The data could be manually entered incorrectly, so a lot of times there might be a human in the loop that is taking data from something or some source and entering it. So if they're putting in an Excel sheet and they make a typo, that can really throw off, the quality of your data. Your sensor could get moved as well. So maybe it was a temperature sensor and someone accidentally moved it into the shade when it should have been in the sun, capturing the temperature. Or maybe the reverse if that's more true. And then again, pipeline, if you're ever doing transforms or anything in your pipeline, there are chances that a schema could change if somebody updates a library or something like that, causing different values to occur. And you just kind of want to run these checks, like little unit tests on your data, to make sure that the data, it looks the way that you're expecting it to. Some data drift examples. So I kind of mentioned this is where the input data going into the model really no longer looks very similar, or it's kind of drifted away from the distribution that was in your training data set. So you trained a model on a specific set of data, and now you have this model in production, and you want to make sure that the input data is probably pretty close to that training data. Otherwise, your model may not be making good predictions. So some common use cases here is like seasonality changes. If I trained a computer vision model on people in the summer, and I was trying to detect people, and they were all wearing summer clothing like shorts and baseball hats and tank tops, and then I was running that same model with the summer data looking at people in the winter, and they're all wearing big coats and scarves and different hats. Chances are, that data now looks fairly different or somewhat different than the training data set. So I want to probably, in this case, I would take that new data, that winter dressed people data, and then retrain a model so it can look at both summer and winter and hopefully do accurate predictions. You could acquire a new group of users. Common use case of this could be like if you trained a voice assistant and it was all on adult voices and they're all a little bit deeper and kids started using it and it might not be able to detect what they're saying as well. And also just consumer preferences change over the time. So if you're running a recommendation model on an online store or something like that, people's shopping trends change over time. So if you're not updating the model with more recent things of like what people are shopping for, again, your model might become a little stale in that case. And I'll ask the chat, What examples have you seen or experienced? Have you ever put in anything in production or even just a toy model and you had a new piece of data come in that didn't really look like the training data set, and how did your model behave? And a quick example of concept drift. This is kind of whereas before it was the input data was changing. In this case, the input data might not have actually changed, but the output prediction probably changed over time. So one example I like to use for that is the housing market. If you trained a model in the housing market 10 years ago and you're still using the same data to make a prediction of the price of the house, so let's say it was just super simple and it was the number of bedrooms and the square footage of the house, that data didn't change, but the mapping of that data to the price probably changed over 10 years. So houses were a lot cheaper 10 years ago. And if you were using that same model, it would no longer be accurate at all. So it kind of grew stale, and you'd want to retrain it with those new kind of Y values, the prediction values. Again, I'll ask the chat if you've seen any examples you want to share. It's always fun to kind of hear about what other people have experienced. Detecting bias in production with segmentation. So again, these are all things we're going to go see hands-on as well. I saw, again, some more people join in. We're going through some slides real quick, and then we'll be doing mostly hands-on portion. So detecting bias in production, someone said they're interested about this. Once you put a model in production, what you want to do is, again, monitor in certain ways like we'll see. But one thing you can also do is segment up that data and see how it's performing on certain groups. So for example, years ago, there was a company that did a credit card, and I think it was women weren't getting approved at a very good rate on it. And I'm sure that's not something that was in the training data set, but it's something that it picked up from features, and for whatever reason wasn't approving that gender at a fair rate. And what you can do in production is kind of monitor segments of your data. So in that case, you could segment it up to the genders and then seeing like what the approval rate was for each of those over time, and catch if there's some sort of big discrepancy between those. And again, we'll see this live in a second with some data. Model explainability. So explainability or explainable AI is a field that explains how models make predictions or makes estimates of like what features are the most important to that model. So for example, here is an example of using SHAP values, which we'll use a little bit later. And it's saying like this feature for this housing data set, I forget what that was. I think it's a tax feature or something like that, was the most important for predicting the price, and then the number of rooms, things that you might think are obvious, but sometimes you'll find features that aren't so obvious, and you can log these again with your model in production to kind of understand, like when you're segmenting your data and monitoring performance, kind of getting another insight of why your models might be behaving the way they are in production. So we're going to be kind of tying all these together today. And again, we'll go through the kind of them one at a time and build upon them. So we'll do data drift first, and then we'll keep adding all these features together and see how we can build a really powerful end-to-end ML monitoring platform. And then just to hammer in, we're almost done with the slides. We'll get to the hands-on part in a second. But just to kind of go over how to think about ML monitoring if you're just getting started out and you've never done this before in a model, realize that you're analyzing a ML application. So you're going to have your pipeline, your model endpoints, your predictions, your KPIs, probably the business values for your companies. So you want to establish a goal in your pipeline where a change can occur. If you don't know where to start, I always recommend just look at the direct input to the models and then look at the direct output from the model. And then if you can go in and annotate some data sometimes to get ground truth, that can give you a lot of insight into your ML application. And then realize that you're analyzing change, some sort of change in your application. So you want to establish a baseline of what is changing. And again, if you don't know where to start here, like this could be different parts of, certain days since model launch, et cetera, golden data. If you don't know where to start, I always recommend if you have a model in production, because you can do very similar stuff for just data pipelines as well. But if you have a model in production, you use some sort of training data set. So what I like to do is log the training data and then compare any new data to that training data distribution. And that can give you really good insight right away on your first day of having the model in production. And that's what we'll do today as well. We'll simulate putting a model in production and then comparing new data to a training data set. And then you want to analyze what's going on. So that's kind of selecting how to measure that change. Again, if you don't know where to start, I recommend distribution distance. So we'll be looking at the data going into the model, the input data, and we'll be monitoring that for some sort of distribution drift from the training data set today. But overall, also, if you can get the annotated data and then do performance analysis, that's always going to be really good as well. All right, so enough slides. This is a workshop. So I'm going to share the Collab link again for everyone. And if you're watching on YouTube, the link is in the description. But here's the Collab link. You're going to want to open this up. This is going to be where we run all the code. And then if you haven't already, you'll want to create this YLabs account. Again, it's free. There's no card required or anything like that. So just fill out the form, verify your email, and then we should be good to go and run the rest of the workshop. And I'm going to copy this link as well. If you want to fill out the survey for a chance to win some swag, we have some fun mugs, some, I think they might be the cutest stress balls. I don't have one in here with me. And then we have new shirts, actually. It says no more MLOps, which is obviously a play on the word of MLOps. And we'll select around, I think, 5 people this round for whoever fills out the survey. And this will be the end of the slide. So I'm going to go ahead and exit out of slide mode here. And I'm going to go to that Collab notebook. Let me know if this is good enough for people. So I'm going to zoom in. Since my face blocks some of this stuff, I'm going to move out to the side again. And you can let me know if this is good enough when we get to the code. But also, you should have your own version of this notebook and make a copy. And then you'll be able to run everything that we're going to be going through here. So open up that Collab notebook file and go to save a copy in Drive. And I'm going to give everyone a minute to do that and take a quick water break. And how's everyone doing so far? I know we just went through a ton in slides, and it's maybe a little bit of a whirlwind introduction to all the ML monitoring concepts. But how's everyone feeling so far? Is everyone ready to run some code and do some hands-on part? So again, open up that link, save a copy in Drive. I'm going to go ahead and do that, so I'll have my own copy to run along with you here. Someone said they're excited. Awesome, glad to hear it. I saw some people just join in. Again, if you want to catch up, we're just getting to the code part. All the links to everything is in the description on YouTube, so you can open up the Collab link and go to File, save a copy in Drive. And then again, the link to YLabs account and everything is here as well. I'll just give everyone a second to go ahead and do that. Somebody let me know when they made a copy, and let me know that the link worked, because I did have an issue with Google Colab the other week, but let me know if you were able to open up this notebook and make a copy in your Drive. At least just one person, just to verify that it works. Someone said, yep, it worked. I see several people saying it's working. Awesome. And sometimes there's also a little bit of a delay from me asking a question to going to the stream, so I have to wait a little extra. If you see a weird pause, that's why. Awesome. Yes to both. Worked. Great. And all right, I think we are ready to keep going then. Again, if you just joined in, all the links to everything's in the description. Just create the account and open up the Collab notebook. So if you've never used Collab Notebook before, it's a really great tool by Google. It's essentially a way of hosting a Jupyter Notebook. And if you've never used a Jupyter Notebook, it's a really popular tool as a data scientist or a machine learning engineer. It allows us to write code, documentation like text and embed images, and see the output from our code all in one place. So it's really cool to kind of do interactive programming. So let's go ahead and run this first code cell. This is going to kick off our own instance. So if you made a copy of this in your Drive, you should be ready to go. You can go ahead and hit this play button. You'll see it's going to be thinking for a second. You'll see up here it's connecting, and it's actually initializing a whole little instance for us to run in the cloud, our code here. And Collab comes pre-installed with most of the machine learning libraries that are commonly used. So we're actually only going to have to install 1 or 2 libraries to go through this whole notebook. So it's going to be really easy, hopefully, for everyone to go ahead and run all the code here and train a model. And then we're going to simulate, like I mentioned, kind of putting a model in production and seeing what it looks like over like a week's time. So here, if you got this green check mark and this returned hello, you're good to go. And it'll initialize its own Ubuntu instance for us here, and we can even do things like running terminal commands like ls. You just put the exclamation at the beginning, and that lists everything in the directory. So in this case, it just comes with a sample folder. And I'm just mentioning this because we can actually use these terminal commands to run things like pip install and actually add libraries to this. And I also just want to note, you can click this play button to run it, but you can also hit Shift Enter. So for the rest of this workshop, I'm probably going to hit Shift Enter. If you don't see me clicking that, that's how I'm running all these code cells. It runs it, and then it goes to the next one. So let's go ahead and install one library. We're going to install YLogs, the library we talked about, to start collecting data and AI telemetry in a privacy-preserving way, where we're just going to be creating profiles of our data set, and we'll see what those profiles look like in a second. Go ahead and run this. This is going to pip install YLogs, and we'll actually see a lot of the requirements are already satisfied in here because, like I mentioned, Collab comes pre-installed with a whole bunch of the libraries like scikit-learn and TensorFlow and stuff. One very important piece before we continue on: once you install this library, make sure you hit restart runtime, because Collab comes pre-installed with some libraries, and it'll have a newer version or an older version of something sometimes. So often if you pip install something and you see this restart runtime, it's good to do it because something might mismatch between that new library you installed. So make sure you hit restart runtime on this button, or if it doesn't show up for whatever reason, like if you run this again, it might not show up. You can always go to the menu, hit runtime, and hit restart runtime here, and then you'll be good to go. So I'm just going to go ahead and hit this button and hit yes, and you'll see it's restarting here, and it's just going to take a few seconds. And now it's restarted our environment, but with those new packages installed that were required. So let's go ahead and import the libraries we're going to use. Most of these, if you've done machine learning before or data science, they might look familiar to you. We're going to import YLogs, again, the library I just talked about, but then we're going to use NumPy and Pandas to look at our data in various ways. We're going to import train test split from scikit-learn, and then we're going to load the iris dataset. But don't worry, if you've ever trained a model or if you've ever done machine learning before, you've probably used the iris dataset at some point. But this is going to get a little more interesting because we're going to look at another iris dataset that we've created that has maybe some failures, spoiler alert, that we can catch with ML monitoring. Has everyone trained with the iris dataset before, by the way? I'm guessing that most people have if you've done machine learning model, but that might be a fun thing to ask. And then we're just going to change a setting in Pandas here so we can look at all the columns in the Collab notebook. And we'll see this CY in a second. So let's go ahead and load in the iris dataset. And if you aren't familiar with it, it contains 3 classes of flowers, and then it contains 4 features. So basically, we're going to train a model to look at 4 different numerical values. Those are the centimeter measurements of petal and sepal length and width. And someone said, yes, they have. I was assuming most people have probably used the iris dataset at some point. At this point, I wonder if it's like the most famous machine learning dataset, potentially. All right. So we have our iris data set, and we can see these are the features, and these are the classes that we're going to be predicting. Now we're going to go ahead and train our machine learning model. Let's go ahead and run this code cell, but I'll walk through it. Again, if you're new to machine learning, don't worry. We're going to be training a pretty simple machine learning model here, and I'll go into intuition how it works in a second as well. But we're importing neighbors from scikit-learn. And then we're using the k-neighbors classifier, and we're setting the n-neighbors to 5. And I'll talk more about what that is in a second. But basically, we are looking at the 5 closest data points to the new data that we want to make a prediction on. And we're going to say, if the majority of those data points belong to the class Versicola, then we're going to make a prediction on that it belongs to Versicola. Here, we're going to get our X values and Y values. X is the features that we're going to be learning from, and Y is the target values that we want to learn how to make predictions from, so the Versicola, Virginica classes, etc. And then we're going to do train test split, so it's common to split up your training data as you're training a model, and you want to have part of that for the learning, and then you want to have part of that to kind of validate how your model works on data it's never seen before, even though it's probably similar distribution-wise. So here we have our X train X test, Y train Y test, and then we're splitting it on those values that we created above. And we're going to save about 30% of the data to do testing on. So we're going to learn from 70% of the data, quickly look at the rest of the 30%, see how our model performed. Random state just shuffles the data in a certain way, but we could always go see how it's shuffled by providing the seed again. And then stratify just means we're going to try to get as even distribution between all the classes in our training data set. And then here's where we actually do the training, where we pass in the X train and Y train, and then we're making predictions on it, and then we're looking at the score. So based on just our testing data set here, it's 97% accurate between a similar distribution of data. Someone said it's the hello world of machine learning. I think that's a really good way to think of it. It is like the hello world data set of machine learning. I think it probably was the first one I did. Probably, I'm guessing it was a long time ago. But if anyone wants to put it in the chat, was it your first machine learning model? All right, so again, just as a quick intuition, we just trained a super quick model here. This is more just to give us a baseline to kind of look at. Now we have a model, we can pass in new data, we can get predictions, and we can understand kind of how to monitor this model in production. And the way that we're going to be monitoring this model in production is very similar to how we would monitor almost any model in production. Or at least classification model. So here, just again, as a quick intuition, if this black data point here was a new piece of data, and in this case, if we're just looking at the petal width and petal length, and the K was set to 4, it's looking at the 4 closest neighbors, and the 3 closest in this case are versicola. What do you think it would make a prediction that class this would belong to? And probably some people are typing right now, but the answer would be versicola because the majority of the closest data points belong to it. Someone said MNEST too is a beginner data set. That is true. I feel like the MNEST one, which is the numbers, right, the digit one, that was the hello world of computer vision data sets for me, I think. Okay, so now we have a trained model. We understand a little bit of intuition how it works. It looks at the closest ones, and this is going to be important when we want to debug our model in production. And this is why it's important to know, even you don't need to know all the math behind a machine learning model if you're using like something like scikit-learn or TensorFlow to build these models. It is important to know the intuition of how they work, because when you want to look at behavior in production, it's going to be very important to kind of know, at least have an intuition of what's going on. So let's go ahead and just go ahead and run this code cell. All we're doing here is we're ingesting like 7 data profile or 7 CSVs here that we're going to use to kind of emulate our model being a run for a week. So each of these is going to be like a day's worth of data. I'm separating out the target, so I'm just getting the feature data here because I want to pretend like we don't have those for a second. You'll see this in a minute. And then I am going to keep the targets so we can add them back in to get things like accuracy and F1 score on them. So all you need to really know right now is we now have a list called data frames DFS that contains all these new batches of data. Again, we're going to use this to emulate like running our model in production for a week. And each batch looks something like this. So we have, in this case, 150 rows in this batch. And then we have the data around our petal and sepal widths and lengths here. And I can access each one by running DFs and then passing in like 0 through 7. And that will give us one of those data frames. So before we run all these batches through our model, we'll look really quickly at creating a log with YLogs. So I mentioned at the beginning, YLogs is a open source library for kind of creating these profiles of data sets, and you can create profiles on data of almost any kind, including images and embeddings. So today we're looking at a somewhat simple tabular data set, but I also do workshops, and we have resources on doing these on like computer vision projects or NLP projects, embeddings, and we have a new project coming out specific to large language models, so lots of really exciting stuff. But it creates these profiles of a data set that doesn't contain any raw data. Just kind of think of it as the summary statistics. We'll actually look at a profile in a second to see what it actually contains. But just with these summary statistics, we can use them to track change in your data set, data in your pipeline, model predictions, and detect things like bias and data drift. And it integrates really easily with probably most of the common libraries that you would be using in machine learning. You can install YLogs in almost any Python environment, including on a Raspberry Pi. So if you actually want to run YLogs on a Raspberry Pi, send the profiles up to YLabs, or we'll also go into, after we use YLabs, we'll also go a little bit more into some of the features of just YLogs itself. So it's an open source library that has cool stuff around detecting data quality issues or data drift. So we'll dive deeper into the open source part of this a little bit down in the notebook as well. But just know the profiles that we create with it are super lightweight and efficient, so they don't contain that much data. So they're very easy to pass around from devices or clouds. There's a lot of customization you can do as well. So if you want to create custom metrics, you can do it as well. And they're also mergeable. So if you're using something like distributed computing, you have different profiles in different places. You can merge them together and keep those statistics intact. So let's create a single profile real quick and see what that looks like. So we're passing in that batch of data that we saw before that had the 150 rows, and we had the sepal and petal length and width values. And so here, this is what a profile contains on a tabular data set. We can see a cardinality estimate. Cardinality means basically how many unique values are in your data set. So even though we had 150 rows, some of those values for each of these columns were overlapping. So there's about 42 unique values in this specific profile. We can see that there was 150 rows. And if we had things like null values or not a number in there, those would show up here as well. But we actually have counts of numbers. So 150 rows had numbers, which is what we want right now. So that's good. And then here are those statistical values. Like I mentioned, we get like the max, the mean, the median, the min. And then we get other distribution metrics like the highest 5% or the top 95% of values. And with just these kind of summary statistics, we have a little bit more, like if you want to see if it's a fractional type, which it is because they're all fractions in here. But if you had types like strings as well, those will show up in here as well. And just with these values, you can do a lot around data quality checks to make sure, again, this data is within the range that you're thinking it should be. But also with things like this min, max, median, if your data distribution changes a lot, you're able to actually measure that as well, just with these kind of lightweight summary statistics, which is really cool. So let's go ahead and do something much more exciting with this profile now. We're going to write this to YLabs. So again, if you didn't create an account, you can do that now. I'll share the link one more time. And it should be plenty of time for you to create an account and catch up. Again, no card or anything required. Just verify your email. So I'm going to go ahead and go into my YLabs account. And it'll look something like this. Yours will look something like this as well, except for you'll have different toy projects at the beginning here. I'm going to go ahead and hit create resource. So we're going to create a new model that we want to monitor as if it's in production. So create a resource. And if you have a couple toy projects, you'll probably want to go ahead and delete them as well. So I'm in my free account here. I'm going to go ahead and delete a couple of these as well. So I'm going to go ahead and delete 1 and 2. So and yeah, all should be good to go. So I'm going to create a new model here. So once you deleted all of yours, I'll just call this Iris Drift. You can call it whatever you want. It doesn't matter too much, but it should be descriptive for your project if you're actually using this. And then we want to set our resource type. So in this case, we know that our KNN is a classification model. So we're going to hit classification here. And then we're going to hit add model. By default, you can change, or by default, the batch frequency is daily. So basically, we're going to ingest all these profiles and look at them, compare them day after day. If you go to a different plan, we have options like if you want to do hourly, etc. So go ahead and add this model. And my model number is 182. Yours will probably be number 2 or 1 or 3 or something like that. But whatever your model number is, go ahead and copy it or remember how to type it out, because then we want to go back to our notebook. We're just setting up 3 variables here to start writing a data to YLabs. So go ahead and put in your model ID. Make sure there's no spaces or new line characters in there. And then I'm going to go from this same page, go to access tokens, and I'm going to create a new token. Again, you could call this whatever you want. I will call it Iris Drift again. Hit create access token. Copy over my access token. Paste it in. Again, make sure there's no spaces or new lines or anything like that. One more value to get is this org ID. It shows up twice on this page once you create the token. It's always going to be right here. And then it's also going to always be right here as well. So highlight one of those, copy it over as well. Put in your org ID. Again, make sure there's no spaces or new line characters at the beginning or after it. And then you can run the cell and you'll be set up now to write data to YLabs. So YLogs creates those profiles in whatever your environment is. So no raw data ever leaves your environment. And then you're able to pass those summary statistics up to YLabs, where we'll be able to start visualizing them and set up automated alerts. Did everyone do that? I'm going to wait just a minute for everyone to catch up and ask any questions if they need me to cover how to get any of these again. Again, once you create your YLabs account, you can go in you should be able to hit just create resource here, but you can always get to this page as well by going to settings and going to model dataset management or access token. And that'll bring you to this page. That's where you can add a new model by typing this in. Again, we want ours to be a classification model. If you already made it and you didn't select it, you can go ahead and hit edit and then select it here and hit save. And then from this page, there's going to be these tabs up here. So you want to hit access token is where you're going to get your API key. Someone said, where in YLabs is this? Hopefully I just showed you, but let me know if you want me to cover how to get there again real quick. So once you create your account here, the easiest way that I like to get to usually is just hit create resource and it brings me directly to that page. But no matter where you are, you can always go to setting in this little hamburger menu here, go to settings and then go to access tokens or that model management. And you can switch between those two tabs to get those values that we just got. And maybe I should have zoomed in a little bit there. Was anyone able to get those values in? So, and how do we create it? If you go into the notebook here, we're just setting that in as an environment variable. So when we read it in, or when YLogs reads it in this case, it'll look for this environment variable set in your OS, and then you'll be able to it'll be able to write to YLabs. The token is for, someone asked what is the token for. This is basically your unique key, so that only you can access your YLabs platform. So this is something you often generate in almost any tool, like OpenAI, for example, too. If you're using that to use a GPT model, you're always going to have your own API key that gets generated. And it's a way of making sure that you can securely access it, and it's going to be a really long, complex key like this that people won't be able to just easily copy or figure out. So I'll keep going. If anyone wants me to go back and get those values again or show them, just let me know, and I'll find a good spot to pause and get those values in. But again, you can go back to YLabs, always get to the settings, and then one of these access token, go between those two tabs. You want the model number that you create, and then the org ID, and your access token. Yeah, someone said using one screen. All right, so I'll go one more time, and then we'll keep going. So no matter where you are, you can go to settings, go to access tokens. If you want to create a new token, just give this any name here. Create access token. This is going to be what you want to copy over here. On the same page, you'll also want to get org ID. Those are the two things on this page. And then there's the model and dataset management tab, which is where you create the model and you want to get that model ID. Once those are over, paste them into the relevant areas, the API key, the org ID, the model ID. We can run this. I'm going to initialize or import the YLabs writer. And then here, I'm creating a profile like we saw above, except for I'm also initializing the YLabs writer. And then I'm calling it to write that single profile up to YLabs. And again, this will look way more interesting in the next code cell after we run it. You can go ahead and run if you want, but I'm going to go real quick into YLabs. And we can see that project that we just set up. There's not a lot going on in this summary tab yet because we just wrote one profile, but we can quickly see it has 150 rows, 4 features. And then I want to go to this input tab real quick. This is going to be interesting to look at, or one of the most interesting tabs to look at right away. We can see there's a single profile for a day. So by default, when you just write up a profile like we did, it's going to be written at the date and time that you push the profile up. But there's a way to overwrite that where we can kind of backfill the data, which is what we're going to do in the next cell. But you can see here, this contains the summary statistics that we looked at in the YLabs profile. So we have the median, the max, the min, and the other percentile metrics that we looked at in our profile. And if I go run the next code cell, all we're doing is the same thing we did above, except for we're just enumerating through each of those data frames, changing the date time down 1 day. So it's going to basically kind of emulate putting our data in the past 7 days. Someone said, and data, where do we get the org ID and data set ID? Again, if you go in and go to settings, the access token tab, it has the org ID once you create a token, but it's also always going to be in here. So you can always get your org ID right here. And then the model ID or data ID is what you create here. So just give this a name and then grab the model from there. So these are the two tabs where everything is contained, is the access token and the model and dataset management tab. All right, so now I had run that other code cell. So if I go back into my data or my YLabs project, I'm going to go back to visualization. So again, sorry if I went a little fast. This is what my homepage looks like. I'm going to click into that project. Again, you might have one project here. Click into it. This is a little summary tab that tells us a little bit about what's going on. This gets more interesting as we add, more things to our project. But again, we're just going to go look at inputs right now, very quickly. If we look at inputs, and then I'm going to just keep clicking on this top one, the petal length. This looks pretty interesting. This gives us those statistics of the profiles over time. So this is now the last 7 days, and just eyeballing this, what do people think? So I'll zoom in a little bit if you're just watching right now or still catching up. Do we think something could be going on with our data here, and maybe why? And maybe if you have a little intuition of what could be going on, let me know in the chat. Or if you think it could cause a problem with our model, let me know in the chat. So just looking at the first day, we can see I'm just going to look, say the median, but you can see the max and min there as well. So the median's 4.2, and then it's 4.3, so very similar, 4.2 again. And then this 6.9, and then this one goes all the way up to 9.2, so that's quite a change in the median of our data set. And then if we look at this one's actually interesting. So the median is 5, which is kind of pretty similar to those first ones we looked at, but the graphic looks way more crazy, and that's because there's actually at least one data point in there. The max is 33, and the min is 0. So that's interesting. The min was never 0 on these other ones before. And then this profile says zeros, all zeros, which is interesting because that probably means that it's all zeros. The min, the max, the median is all zeros. That's pretty interesting. Someone said the flowers be wildin'. Yeah, so there's at least something's going on here, whether the flowers are going crazy in themselves or we have some sort of data mismanagement, like it could be a data quality issue, etc. Someone said they have an error in Collab. Feel free to share the error in the chat. I'm going to keep going for this minute, then I'll come back to it when we get to a good stopping point to hopefully help you there. So we can see quickly by analyzing this with our eyes and looking at the visualizations that something's probably going on here with our data. Again, the median has drifted a lot in these ones, and this one has some crazy values. Like, do we think a petal should ever be 33 centimeters? Like, I don't know. Probably not. I don't know enough about iris flowers, but I'm guessing that's a really long petal. And according to all their other data sets, that looks really out of place. Also, should a minimum ever be 0? And that's a good question. That's something you might want to come up with if that could be a data quality issue for your data set. Maybe 0 would mean that the petal didn't exist or something. Someone said, will they have access to the recording? Yep. The recording will actually be at the same length that you're watching on right now. So someone said, are there some outliers in the data set? That's what we're thinking, right? And this is cool that we can visually start inspecting our data this way. But what would be even cooler is if we didn't have to come manually look here, and we could just set up anomaly detection alerts. So if the big change like this did happen, that we're automatically going to be alerted to it. So real quick, actually, go ahead and run this next code cell. What this is going to do is write that a reference profile of our training data set. So I had mentioned at the beginning, if you don't know where to start on ML monitoring, what you might want to do is log your training data set and look at any new data in production and compare it against your training data set. So basically, what we're going to use is this profile to compare, does this distribution match our training distribution? Someone said they're getting insufficient data available for a time period. We'll have to go make sure in a second maybe that your data was written up. One other thing is sometimes these time periods can be set up here. So if you would just want to inspect one day or something, you can. And it might look something like this or not be a correct date selected at all. And you should have this batch profile lineage section that you can just tap on, and this will bring you to the view where you can look at all the data that was ingested. If that's not the case, again, let me go through at least setting the monitors and stuff and a couple other code cells, and then we can walk back and maybe look at what could be going on in your Collab notebook. Potentially you missed a code cell as well. Could be that could be it. So let's set this up so we don't have to manually go look here every day and see how our data is performing. I'm going to go click this button, set up monitors, but you can always get to the same area by going to this monitor manager tab. So we're going to hit set up monitors here. You can create a whole new custom one here, or you can even get really into it and create them with JSON if you really want to customize it. But let's go ahead and start with something easy. We have presets made here. If you want to detect drift, data quality issues, model performance issues, ingestion health, we kind of have some preset things to make it really easy to get you started setting up. So I want to do one on data drift. In this case, this is the input data in production, and we want to say when this looks a lot different than our initial training data set, alert us and let us know so that we can go look at it and debug what's going on here. So I'm going to go ahead and hit configure so we can see what is going on behind the scenes here. And again, we're going to be looking at drift. And then we're going to be looking at, in this case, the entire data set. We're going to get to segments a little bit later in this notebook if you want to stick around. But in this case, we're going to look at our entire data set. So it's going to be looking at all those values that we saw before. I'm actually going to tweak this a little bit here. So we use something called the Hellinger distance in YLabs to calculate the drift distance between values that we're comparing against. So in this case, we're going to be comparing against those 7 days of production data. We're going to be looking back or comparing against our training data set. So we're going to say, if this changes a certain amount from our training data set distribution, trigger an anomaly detection. And then this next area, if you don't have any training data sets to start doing the comparison on, you can do a rolling window. And again, this is going to be really good too if you don't have like a golden data set or a training data set and you're just monitoring data in your pipeline. You can be looking back at anywhere from the 7 to 90 days and seeing if any anomalies occurred there. Like, the first 7 days of data looked normal. All of a sudden, the 8th day looked really crazy, and it doesn't really match what was coming on in the first week. You can set it up so you can get a anomaly detection that way. In this case, we're going to set up a reference profile, though. So we're going to be comparing all that new data, look at our training data, and if it looks different than that distribution, trigger an alert. And you can also set up how these alerts work. So you can kind of set a severity level so like, oh, this is high or it's not a big deal. I'll go ahead and set this a medium. It doesn't really do anything for us here in this workshop, but it's a good way of kind of segmenting out alerts. So if it's going to be a high priority or a lower priority one. And then where should the alerts be sent to? You can easily set up email or Slack integrations in the setting tab. You can also set up pager duty. So I talked about building out that kind of loop in your MLOps cycle where data change happens. You might want to kick off some sort of automated or crowdsourced data annotation job. You could use something like a pager duty integration to do that. So let's go ahead and hit save. Let's go back to our input tab. We'll go look at our pedal length again. And now we can preview our monitor. So by default, you can actually see it's going to run in about 1 hour is what it says. So by default, it's going to be running every single day and looking at that new days of profile and comparing it against the training data set in this case. So this should just take a second to run. And then here we can see that on these 3 days that we kind of eyeballed and looked at the visualizations and looked at the numbers where we thought something might be wrong here, we are able to catch that now with our kind of automated anomaly detection. So we wouldn't have to come look here every day or every hour or something like that. You can actually just set up alerts to ping you on Slack or send you an email or anything like that. So first of all, I saw someone put the error in. That's cool. I'll come back to this when we get back to the notebook. And it looks like one of the errors is actually in the, not next whole section, but in the logging output. So we'll run it in my notebook and see what happens there. But this is now, we've gone through and we're able to detect data drift happening with any input data in our model, which is pretty cool. What does anyone think of this so far? Does it seem interesting or useful? Have you ever, again, experienced something like a data drift happening in a model in production, whether that's like a toy project or actually in production, where data change occurred and then your model was no longer performing well? And someone asked, can you build a model for image recognition in the platform? Yeah, so you can use this for computer vision models. And I think I might even have a model still in here for computer vision. And you can, extract different distribution metrics from your images or bounding box detection algorithms and then log those here and do something similar. So you could see if like images, the lighting drastically changed, for instance. You could do that in this platform and catch data drift for images or embeddings. So I'm going to go back and let's go ahead and I'll keep going here. And someone said they had an error in this part in the code cell. So let me see. I'm going to go ahead and run this next part. All I'm doing here is I'm running the each day of those data frames into our model. So I'm going to get our prediction scores, so the class prediction, and then the probability output. So basically it's going to say, I think this is versicola, et cetera. And I'm like 80% sure, confident that that is the case. I got a little warning here, I think, because I didn't do something super efficient in pandas, but not the error that someone else was mentioning. And then if I look at my data frame here, I now have the input data like we saw before and the class output data. So we have the output prediction, and then we have the probability score from our model. So I'll write this up to YLabs next, and then maybe I can help someone debug anything that's going on in their notebook. So very similar to like we were doing before, where we were writing up the whole data, except for in this case, we're just passing up those two columns. So we're just going to write the classification output and probability output columns from this from this data frame. And if we wanted to, we could do this all at once. And in fact, when you go a little bit further down and look at bias and explainability, we actually do this all together just to make it a little bit quicker, because we're going to make another model with that. But I'll also just note real quick, so if you're actually doing something in production, this is an example of using YLogs and YLabs with BentoML. So you could deploy like a model with BentoML framework, which is makes it really easy to create like endpoints and version your models. Here I'm just creating a data dictionary that contains all those features and then the category and probability output all in one place. So if I go back to YLabs and now I click this Outputs tab, we're going to have those two outputs that we had created, which was the class output and the probability output. And they go into this tab because we included the word output or some variation of that. So it could be output or outputs that'll automatically go in this output tab. And that makes it really much easier for you if you had a model with like hundreds of features or something like that. I know in this case we only have 4. So we have this output tab here and some other features too around monitoring like if the output changes. But here, let's go click in class output, and we can look at our frequently predicted items for the 7 days, just like we were looking at input data, but now we're looking at the output data of our model. So we can see the first 3 days have a pretty similar distribution. And when we ran the data drift monitor on our input data, we saw that those 3 days were pretty similar to the training data set, so they're probably pretty fine. And I'm cheating because I know they are, because I made the alterations to this data set. So we can tell that in this case we're expecting probably a pretty similar distribution of like about 50 of each class every single day. And then on this one, we can see it's almost all one class, so that's kind of weird. And this other one, where we also saw the data go a little weird, but the median was about the same. The distribution looks a little different here, but closer to these ones. And then this one, which we saw was all zeros, is all one class. So that's kind of interesting. And then this distribution, again, it looks pretty similar to like it did before. And then if we look at this probability output, this is now the numerical score. Like I was saying, it's kind of how confident the model's feeling that it belongs to that class. And you can see some variations in those 3 days that we know are kind of messed up as well. And one in particular that's interesting is on that day where it's all zeros, it says it's 100% sure that all of them are this certain class. And that's interesting. And the reason why it's doing that, if you remember the intuition of k-nearest neighbors, is, we didn't set up any data quality validation. Like we'll see a little bit later that we can actually use YLogs to do this in your environment. But if we had a new piece of data that was all the way over here, let's say was negative numbers, we don't have anything checking for that. So it's still by default, the nearest neighbor machine learning algorithm is still just looking at the closest 5 nearest neighbors in that case. Doesn't matter how out of distribution they are from our training data right now, because we didn't set up any guardrails for it. So basically, it could be negative numbers in this case, or all zeros, because we know that profile is all zeros, and all the 5 closest neighbors to it are going to be Setosa. So it's like, I'm 100% confident that this is the class it belongs to. Nothing else is even close to me, and that's really interesting. So it's good to think about, you know, the kind of data quality validation things you might want to put on your data before you make model predictions. All right, so I'm going to go through just a couple more cells, and then we will be at a good point for me to help debug someone's notebook. So I just want to show off kind of the other last piece to this section of the notebook, and then we will go into the bias and explainability piece next, as well as the open source part. So let's see, did we run this? I think we ran that. That wrote up the output data. Let's log the performance real quick. So now this is what our notebook looks like, just like we saw before. So we had the class prediction and the probability output. And then here, now we have a new data frame that contains the ground truth. So now we can log the metrics like accuracy. We actually know what the values were. So for example, if this was actually in production, like I'd mentioned, maybe we saw that the data drifted, and we could kick off a crowdsourced data annotation job using different tools. There's one I did a workshop on called Toloka, where you can actually integrate with like a PagerDuty API. Makes it really easy. So this is part of your MLOps loop now, where the data changes. You want to make sure that your model still is performing well. We could look at the outputs and get some gist or idea like we just did. But honestly, having ground truth and measuring the real performance, at least on some portion of the data, is going to be amazing to have. So again, we could kick off an annotation job, or we could go in and manually label some. And then so in this case, it's like we had that happen. Now we have the ground truth, and we're going to actually compare how our model did. And we can, again, visualize that in YLabs here. And all I'm doing is taking that data frame, and I'm using something called .log classification metrics. Again, you could do this for different metrics like linear regression, etc. In this case, I'm logging up the ground truth and the class output. That's how these metrics are going to be calculated. And then I'm doing the same thing where I'm looping through each of those data frames and logging them for each day that we went through. So if I go back to performance now, we'll have a tab that looks like this. And we can see that, again, those 3 days that we saw trouble with on data first, we can confirm that when we did have annotators come in, our model dipped a lot in accuracy on those 3 days. So our model definitely wasn't performing well on that variation of data. In particular, right, on all zeros, it's 33% because it's just always making one prediction. So it was 1/3 of the time it was right because like, what is it? The clock is always right once a day. So we can see that definitely did affect these models looking at our ground truth performance. And you can set up monitors on these as well. So this can come back to the MLOps loop like we were talking about, where maybe you had someone annotate data. Now you have this annotated data, which is really cool. You can train a new model with those different variations of this and deploy that new version of the model that was trained on this new data. And you could do something called shadow deployment, where you're now kind of just, that model's out there and you're comparing those predictions to the past one. You can compare multiple models here. And then so if one model is now performing better than the old one, then you could deploy it into production. All right, so I am at a point now before we go in to the next section. If anybody still has an error on their notebook they want me to try to troubleshoot real quick, I'll take a minute to do that. I did see someone saying they were going to drop off because I think it's early in the morning for them, and their phone is blowing up. No worries, and the recording will be here. And if you have any questions, again, if you want to connect with me in the Slack channel, that's going to be a good place to ask questions later as well. But the recording will be at the same link. And we'll also make sure we send out an email. So if you registered on Eventbrite, you'll get an email with a recording as well. Is anyone else still here that had an error in their notebook? If you do have an error, I'll throw out a couple things that could be before we move on. One, if you weren't here at the part where I really emphasize to restart your runtime. This can throw an error because you won't have one of the libraries will have a conflict with another one. Also, a common error is just missing one of the code cells. It's really easy to, like, I do this all the time where I think I ran a code cell, but I didn't. So if you are getting an error, make sure that you actually ran each of these code cells in order. So if you weren't sure, you could always come back at the top and start running them all again. You can also always hit, if you want to do a complete refresh on this notebook, hit disconnect and delete runtime. You're just going to have to pip install and restart the runtime again, but that'll give you a fresh reset on this. Or if you made a copy, you can always go back to that original link, make a new copy from there, and run all these code cells again. Because I ran it on mine, and I didn't get any issues. So there might be something also that you entered wrong in the API key section. Again, something that I do is I accidentally might include a space at the beginning or end of one of these strings. Just make sure you don't have a space at the beginning or end. Make sure you don't have a new line character like this where one of these tabs is down below. And those should be the common issues. Occasionally, there is also a Collab issue if it's been running for a while and you weren't interacting with it and it kind of went to sleep or something like that, and you try to push profiles up to YLabs, you might get some sort of SSL cert error as well when you're trying to push data out of it. So it could be one of those things probably, but I don't see another comment from anyone else. If they still had an error, they might have dropped off as well. And I also just will pause real quick. How's everyone doing so far? Someone said variables, and it was throwing 404 used name instead of ID values. Typically, that's going to be something, I think, if you're talking about, it was one of these, or I think this is where you probably got the 404, or maybe set it up when you're trying to write to YLabs. Also, make sure that these are in the right places. That could be another thing, actually, as well. So make sure that the model ID is in this model ID section, like you didn't accidentally paste it into the org ID or the API key. Someone said they figured it out and it's fixed. Awesome. Was it one of those swapped around potentially? Always good for me to know too. So the next time if someone runs into the same thing, I can troubleshoot it quicker. All right, so I know we've gone through a lot already. We still have some more stuff to go through, but I just want to take a quick pause again and ask, how's everyone feeling? And are you following along? I know I'm sure not every single person's following along. If you are, is it interesting? Does it seem like a very cool tool, something that you'd find useful putting models in production? Have you ever used anything like a method of looking at data drift or data quality issues before? Like I know for me and other companies, there's a lot of like manual tests people might do, or you manually go look at a camera or something like that to make sure your data isn't having some sort of quality issue. But this really saves you hopefully a lot of time and stress from you thinking about it, but also depending on your application, if your model goes down or is doing bad predictions for a while, that can be incredibly costly. Or hopefully you're not doing something where like there's some sort of human life involved or anything like that. Anything for model drift other than data drift? So yeah, if you go in, and again, we're not able to go to every single way of setting up drift in here, but if you go into like the monitor manager, for example, and our documentation, there'll be a lot more around like custom monitoring metrics that you can set. So you can set different types of metrics and ways to detect drift in your data. But one thing too is like if you go look at these presets, again, there's some stuff around like data quality that you might want to be looking at. And also you might want to be looking at different ways that your models are performing. And you could also set something up about looking at your model outputs. So in this case, we were just looking at input data, seeing if it drifted. You could set the similar thing up for your output value and actually set up a monitor on something like these classes, for instance, right? We could say, well, these distributions are very similar. Whoa, this one looks way different. This one looks pretty different. These all three look pretty different. And you could also get an alert set up that way as well. Someone said they've been following along with you, and it's all working. Awesome, thank you. Yeah, and I mean, obviously, again, like I know we're going through things pretty fast, and I do hope, like you said, then it will be good to go through on your own. I hope this is going to give you like a really good crash course in all these things, and then you're able to take this and implement it like in your own project. And I think I missed it. It's up there somewhere. There was a question about different data drift metrics. So like we were saying by default in here, we use Hellinger distance. We'll actually look at a little bit more too with YLogs, or if you want to jump to that, you could scroll down. And somewhere in the copy down here in this kind of open source section, there's a link to setting up different statistics in YLogs itself. Someone asked a good question. So once you detect data drift, in this case, how do you fix issues and retrain the model? So like I'd mentioned here, one way of doing it, like how I would probably approach this right now, is I would set up some sort of, I call it like an MLOps loop. I guess there's different ways of saying it, but I always kind of think of these things as a loop where, you know, you're training, you're evaluating your model, you're deploying it, you're basically looking at how it's performing over time. And then you're often retraining these models. Very like few models are just put out there and then never touched again. Most of the time, you're going to be constantly improving these models. And so, like I mentioned, we see there's a data drift issue here. We go okay. We should go probably look at that raw data, maybe in this case. So we're probably collecting our data somewhere as well in our environment. And then we could, like I mentioned, one thing I would do is either I would go in and do the data annotation myself, or I could have data annotators or again, there's a whole bunch of tools that make this easy to crowdsource it. I would go get that data, maybe even go inspect it further to see like what those specific variations are. Like, for example, this flower is a 33 centimeters. Is there a way for me to go verify that that was true? So in this case, if it was somebody manually typing it, like, is there a way for me to go talk to that person or something like that and see if that's true? Or do I just know for sure there's no way that that's true and they meant to type 3 and they accidentally clicked it twice? That could be the case. If you're doing something like computer vision, maybe you actually have those images stored and you want to go see what they look like. So this gives you a really good point to go further in and debug your data for those. In this case, like, I know which day it's on, I could go look at that batch of it. And there are ways too of logging a little bit more information around like file names and stuff that make it even quicker to get to. And then now that I have that kind of annotated data, probably that either I did or someone else did, I would take that annotated data, I would retrain our model. And I would only take that newly annotated data, by the way, if it's like accurate. So if I knew that 33 shouldn't exist, then I wouldn't take that new data and retrain my model. I would just get rid of that data probably completely. Well, yeah, I mean, it depends. Someone asked other tools to fix issues. It depends on the type of issues. So, I mean, if you're, again, want to do data quality validation, that's something we'll look at with YLogs. And in that case, if we knew that 33 should never be possible, what we can do is actually just stop it in our environment and never make it go to the model. So we'll see how you can do that. But otherwise, it's often tying these kind of tools together. So you might have your ML orchestration framework, like Airflow or Flight, and you have your trained model there, and you're collecting data. You're getting statistics from YLabs. You're triggering something in PagerDuty. You're saying, hey, something's wrong here. Let's go take a deeper look at it and maybe even get new data and train or retrain a model. I'm not sure if you have another specific tool in mind or like specifically what you're trying to fix. It just varies a lot on how your pipeline is set up and like what type of data you're using and the source of your data. I think someone wrote it out really good. They said detect data quality issues, then set up ML monitoring, plus alerting, anomaly detection, creating custom monitors, and then basically all of that in one place. That's often what your whole pipeline might look like by the end. And sometimes you don't have to start with all those. Like, you can start piecing them together. But yeah, like a mature pipeline will have probably most of those types of things. And then ways to kind of trigger a new trained retraining your model and then deploying that model. And I mentioned there's something called shadow deployment, where you can kind of deploy your model, but it's not actually making the decisions for like the customers yet, let's say, like if you're doing product recommendations, but it's making predictions, and then you can compare those predictions between both of those models. And then when you verify, yes, the new model is way better, let's go ahead and put it in production. That's a really good way of making sure that you're always increasing the performance. And they do that a lot in like self-driving cars, for example. Like there might be a Tesla and they have one version of the self-driving out, and they'll do a shadow deployment with the new version before they put it out, especially in that case, if it's like driving a car, that's, you want to be as safe as possible with that. So they'll do shadow deployment where the model's basically giving feedback how it would make predictions, but it's not actually steering the car yet. And they use something like monitoring in that case as well. So like if there's, data that they don't have yet in their model, they'll want to capture that new data. All right, so we took a good pause. Hopefully I've answered a lot of questions that people had in the chat. Again, if I didn't get to it, join the Slack channel and ask it in there so I can get to it later. And I apologize if I did miss one. I'm not purposely trying to ignore it. But let's keep going. We're going to look at some bias and fairness features and explainability. And I'll try to go through this pretty quick, I think. And then we'll go into the YLogs open source features. So here, this is actually going to be, the first part is like going to be really repetitive to what we did before. So I'm really going to go quickly through these first cells. If you were here at the beginning, going through all the other cells, these top like 5 or something like that are going to be like pretty much exactly the same. And then I'll stop and pause when it gets to the different stuff. So here we're doing our library imports like we did before. We're getting our iris data set. We're going to train a model. We're just going to train another model. It's exactly like we did before. We're going to get batches of our data. This data is very similar to before, except for there's one difference, basically. The data is actually different in here, but basically we're ingesting 7 data frames again. And it is for iris data or variations of iris, but the data is going to be different. And there's one key big thing here is we now have the location for where each of these flowers was grown. So we have a state that they were grown. There's Washington, Florida, and Missouri, I believe. So this is what we're going to use to segment and see if our model is kind of biased towards any of these groups of data. And in this case, we're doing something, again, it's a kind of a good showcase of a toy model using the iris data set. And then we have a state of where these flowers were grown. But you could easily see how this can go into more like protected classes of like races or gender or age. So if you're making sure like in healthcare or something like that, you want to make sure your model isn't completely biased towards any of those things. You can add a kind of segment to your data and models in production and see how it's performing against those. So in this case, again, it's flowers in state, but it could be something much more serious, right, in production. So again, we're going to create a profile. We already saw what our profile looks like. It's very similar to before. And then just one thing. So if you already followed along, all you need to do is create a new model and just put in that one new model ID. If you just got here and you were able to catch up somehow already, you could uncomment these and put in your org ID and API key. But I'm just going to go ahead and get a new model ID because we already set our API key and org ID above a little bit earlier. So I'm going to go back to YLabs. I'm going to create a new platform, a new project. And I'll call this iris segment. And again, this is going to be a classification model. Oops. Classification model, add a new model. Now my new model ID is 183. Again, yours will probably be a different number, so just copy over what this is. Make sure there's no spaces again or anything like that. Run that, and now we'll be writing data to this new model. So we're going to write data very similar to like we did before. I'll go ahead and just run this. This is actually us making that data frame like we saw before combined with the predictions. But we're just going to do that up at the beginning. So now we have this data frame where we have our features. We have the state that the flower was grown in. We have our class output and then our probability output. So now this is very similar to us writing profiles to YLabs before, except for we're using something called segment on column. So there's different ways of setting up like custom segmentation for your data. In this case, we have that column there with the states. We're going to segment on that. And you can read way more about segmentation and YLogs here. So if you want to see all the different custom stuff you can do with it, go to that link. But for now, we're basically looking at our data set, and now we want to be able to monitor set monitors and visualizations and all that stuff we saw before, and some other features that will really kind of help us figure out what's going on in different states here on the different states in the column. So basically, we're treating those states as 3 segments, and then we can do all the cool stuff that we saw before and more with it. So if we go back to YLabs now, and I go to this iris segment profile, we can see this is similar to like we saw before, but I want to go to, wait, let me make sure. Oh yeah. So before I do that, actually, I'll just go ahead and run these other code cells, and then we'll look at everything at once. I think it's going to be easier. Sorry for the back and forth. So we ran this, that wrote up our profiles. That's great. We can actually already start looking at some of the segments. Let's go ahead and write a reference profile again here. And then here we're going to write up the classification metrics just like we did before, except for, again, we're going to segment on state. So like we're going to get the accuracy, F1 score, etc. But we're going to be able to inspect that by different states and see if how it compares. So like we could see, you know, is the state of Florida as accurate as the state of Washington data? And again, you could use these things for like, is your model, you know, as good at predicting diseases on people under 20 or anything like that? All right, so now we have all of our cool segmentation stuff in here. If I refresh, it should have some data in our tab here where it actually says we have 3 segments that we could look at. We have 5 features. We had those 4 that we had before, plus the state one now logged. And I could go to our input tab. This is all the stuff we saw before. You could do all that cool stuff again, like we saw before. But what I'm going to do is let's first go to this tracing tab, and then we'll come look at the segment one again. So we have this feature called tracing, where it allows us to really kind of dive in and visually look at whatever we segmented however we segmented our data. And this really allows you to kind of find like, you know, really hard to see things in other visualizations. Like if we just went and looked at the input data, again, you don't have to switch tabs or anything like that right now. But if I looked at the input data here, you know, before it was easy for us to kind of visually see that something might be off. In this case, you know, our input data looks fine, but I'll give you a quick hint. There could be some hidden bias in here. So if we go to our tracing, and we can actually already see just the default values here is accuracy and prediction. This is the big bar here. And then we have a secondary metric that we can look at. And I might want to look at false positive rate. So that's this kind of little bar, hard to see there. Again, I could zoom in. You can see it's like a little metric down there. And we have this threshold we can set here. So we're looking at, let's say we want to make sure our models are going to be performing at 90% accuracy across all of our segmented data. Can anyone tell me what could be going on here just from this visualization? Well, Florida isn't as accurate. It's still maybe not super bad depending on what our application was. But if our target goal is always to be 90% accurate, Florida is overall from all those profiles ingested over the 7 days here is only 80%, about 81% accurate. Whereas the data we have for Missouri and Washington are all above 90. So in this case, just with this visualization, we can kind of quickly tell that our model is not performing as well on the data in Florida. And so maybe one thing that happened is like Florida has longer flowers or you know, longer petal lengths, for example. And maybe all of our data collected that we trained our model on was in Washington, where they're all a little bit shorter. And if that's the case, you know, again, our model might be biased towards this Washington and Missouri data and maybe wasn't really trained well enough on the data for Florida, so the accuracy is down. And so again, this just is like 3 features. We can have a ton of different features, and this is a really good way of kind of finding. I think we like kind of like a needle in a haystack. Like it's hard to inspect your data sometimes and see how it's performing in different segments, and this really allows you to kind of quickly visualize it and set up monitors on this as well if you wanted. And if you wanted to, you could also compare profiles. So in this case, it's looking at all the profile ranges. We could look at what it is overall compared to specific days, or you could select other specific days. So I think I chose the same there. You know, one day it actually was way more accurate versus another day. And this allows you to kind of visually drill down how your model's performing on different segments. And someone said, how do they delete a data set? They're getting the over limits error. So I'll go to the segment tab in a second. I just will cover this real quick. So again, go to settings or wherever you're trying to create a new model, hit model or edit models and dataset, and then this delete button will come up and you'll be able to delete them there and then just hit save and you'll be able to create a new one. So I'll go back to my segment project. Now I go to the segment tab. This allows me to investigate data just like we did before, like for data drift or outputs, but very specific to, in this case, those 3 states. Again, this could be like ages or anything that you want to break, any way you want to break down your data. And then we could look at what, petal length or sepal width and stuff like that looks like specifically for, in this case, Florida. And we could see if there's any anomalies here that we think is way off. Again, this one, the max is way higher. So like we were saying, maybe it was like the sepal length is much longer on our Florida data and our model just wasn't trained for it. And so the predictions aren't as accurate. So then it's easy to switch to different segments from this tab up here. And then something that's also very useful. And you can set up monitors on specific segments as well. So you could say like, alert me when Florida distribution changes a lot because we think there's more variations there. Or again, if it was set up for different ages in some sort of medical facility, maybe that's more important. Like, hey, if the data drift for older patients changes a lot, that's a higher priority alert. We can also set up or look at performance between all those different segments very easily. So again, this is looking at all the data. So you can see here, it's this kind of greenish line or blue line is Washington, and the orange is the overall data set. So we can actually see that the overall is a little bit less in Washington. We can compare, let's say, Florida, and we can actually see that in this case, the state of Florida is a little bit below average for all of the other ones. So again, this is a great way of being able to dive in to your data a little bit more. Someone asked, is customization of some metrics possible, such as defining your own anomalies? Yes. So there's a lot of customization you can do around specifically like any type of data that you want to log. Like we were just looking at the kind of out of the box stuff today on tabular data. There's a lot of customization you could do on the YLogs side, and then as well as on the ML monitoring side as well. And again, if you have more specific questions around like setting that up for your project, let me know in Slack, because I probably won't be able to get to it right now. But if you want to join on Slack, or if you connected with me on LinkedIn, you could also message me there. But if you have questions specifically around like a custom metric for something that you actually do want to monitor, let us know in the Slack channel, and we can help you figure that out. All right. Did anyone think this is a kind of a cool feature? Pretty interesting how you can break these down by different segments. And again, like just to clarify, because I went through pretty fast, we didn't use the state in this case. Wasn't anything used in training of the machine learning model. So it wasn't really a feature for a machine learning model. It's a way that we could segment our data later on and see how it's performing in production, right? So again, a lot of times you'll want to segment on data that isn't a feature of your data, but you could do that as well if you wanted to. But in this case, again, like I think I'd mentioned the credit card, not approving women over men. And that wasn't something explicitly in the data set, but you could add these segments later and see how it's performing on those classes in production. And if you do have that, the custom metrics question in Slack, there is a YLogs or a YLabs channel that would be good to ask it in as well. All right, so if I go back to our notebook, we can look at feature importance real quick. I'm going to use SHAP values. You might have seen these before. I'll go ahead and hit pip install because that can take a minute. SHAP values are a really cool way of extracting different values about your model and try to understand why they're kind of behaving the way they're behaving. They have stuff around tabular data, like we're going to use today, to kind of get the most important feature from your model, why it's making those predictions. So if you want to call out real quick, before we run it, what feature out of petal length, width, and sepal length and width do you think is going to be most important for our iris data set? Or maybe you remember, if you looked at it before when you were learning machine learning, what do you think the most important feature is going to be? But SHAP has a lot of really cool stuff around looking at these metrics in different ways. We're going to use something like this today, so we're just going to get the overall importance for our model. But you can also do it on specific predictions. You can also use it in different types of data sets. So if you are using something like transformers, you can get kind of the most important words for the sentiment prediction, is like what they show here. I really like looking at this too. And I've done a lot of computer vision stuff in the past. So I think it's really interesting seeing how computer vision models behave. So this is looking at, why is it making the prediction that this was a meerkat over a bird or something like that? And it turns out that for this specific model, detecting if it's a meerkat, it's like specifically looking around the eyes. And that's something that's unrelated to this workshop, but it's kind of interesting. I feel like a lot of stuff I've done with like animals, and if you do it through an explainability algorithm, it often is looking around the eyes. Even if you think like, as a human, I don't know, trying to decide if it's a cat or a dog, you might think it's the ears or something like that. It's something I've found is often around the eyes, which I thought was interesting. But it's a cool way of kind of understanding why your model might be making predictions. So like if you had a false prediction on an image, you could run that image through something like SHAP, and maybe it's highlighting specifically, this area of the image, and you're like, oh, it kind of looks like the eyes of a meerkat or something. So here we have SHAP installed. Let's go ahead and import it. And then we're going to use something called SHAP Explainer. That's the thing we kind of looked at before. We can already see what we're going to get. We're going to get the value importance for our model overall. Basically, we're getting that by passing in all the test data sets. And then it's going to figure out what was the most important feature between all the test data to make predictions. And so here, I don't think anyone wrote a guess of what it was going to be, but it's petal length. So it turns out that, petal length is actually, according to this chart, by far the most important feature. And something that's kind of fun when you do this is you might have ones that are really low, like this sepal length. You might even just remove that feature from training a model and see how your model performs. So if we just use petal length, it'd be interesting to see how our model would do. So let's go ahead and log this up to YLabs. We're just extracting the features here into a dictionary format. And then we're calling the YLabs writer, kind of like we've already done a couple different times, except for we're using the feature weights. And what this is going to do, it's going to write up our feature weights that we can see here. And they're going to live in the platform now. So if we go to the explainability side. Uh-oh, did I do it right? Did I run everything? Maybe it's still taking a second to upload them. Live demo. Let me make sure I have the model set right. Did anyone else run it and did it work for them? Should be working for me. I think most likely I did something stupid in here. And it would be really funny if someone else did it and they're like, oh yeah, it was fine for me. Well, if it doesn't show up here, I'll have to double check what went wrong. Someone said it did work for them. Awesome. I don't know what I did. Did I not change the model number or something? I'm sure, again, it's usually like a missing code cell or something like that I probably didn't run. That's so funny. Well, I love that it worked for you. If I can't get it to work, I'll just talk through it real quick. And if you followed along, someone said check selected resources. I think you're talking about this, right? Yeah, that's funny. It worked for everyone else. I don't know what went wrong with me. Again, I'm sure it's me being stupid. But yeah, if you are... Oh yeah, let me see if it's in a different one. Let me try writing it up again real quick too. But if you already have it, you can start playing around with the features there, where you'll have a graph that looks like this telling you the importance of your data, and you'll be able to click into like petal length and petal width and sepal width, etc. And this is really just a good way of kind of understanding your model in production. So if you train a new model too, you can also compare both of them together and see like if they still have the same feature importance or if it changed at all. You'll see that kind of comparison tab in there. And then you can also easily click on this and drill down. So you can like quickly set up a monitor on the most important features. And you can, I think, auto set monitors on that too. So you can grab the most important features and then automatically set up a monitor there. I swear I must have skipped a code cell or something like that, and I can't figure it out. Unless anyone sees me doing something wrong. But I love that it worked for everyone else. This is the first time I've ever had that happen where something did not work for me. That's so funny. Well, like I mentioned, I think the coolest part there is like if you train a new model too, you can compare those feature importance together. And you can see for the people that it worked for, I'll have to see what happened on my end. You can click down and easily set monitors and stuff on whatever the most important values are. So maybe you don't want to monitor necessarily on the sepal width, or you want to set the severity and change it on those different ones based on the feature importance. You could do that there. I'm going to run this one more time on my end just to see. And if not, I'll just check later and see what happened there. And I'm sure it's something really stupid that I just missed probably in my code or something like that. On my end, I probably didn't run something, I'm guessing. But I don't want to troubleshoot too long live. Yeah, someone said, or maybe you wrote the output on the same model ID. That's kind of what I'm thinking. I'm going to go, I'll keep going on the YLogs part, and then I'll come back to this maybe a little bit. I don't want to keep everyone too long for me troubleshooting something that I did wrong here, especially if you were able to see it. The main thing I want to point out is like, it's cool that you can have those features, compare them, easily drill down. And it's just like another layer to have in your model. All right, someone's really adamant I go double check my value. But it should be the segment one, right? So I think I should be good. It's 183. It's the last double check I'll do, and then I'll move on. I don't want to bore people with me troubleshooting this. 83. I'll come back later, and we can always revisit it too. But if you did get it to show up for you, that's great. I'll double check one thing. Maybe it wrote to a different date or something. Nope. Okay, I'm going to keep moving forward. If you saw it in yours, great. You can play around with that feature. Like I mentioned, it's a great way of kind of just adding another layer about your model into it so you can kind of more quickly debug it. Someone said they need to jump off. Thank you. Yeah, thank you so much for coming out. And if you do want to catch the last of the bit of the recording, it'll be here at the same link as well. All right, so let's go ahead. Real quick, I'll pause because we're at a good pausing point. We're going to go to the next section where we'll go into a little bit of the features in the open source library. But any other questions besides why my explainability thing didn't work? Any other questions or comments on the kind of being able to drill down with tracing for bias in your data set or models? And again, links to learn more about that are in the notebook, usually in those sections. So for the tracing, for example, there's a lot more you can do with segmentation in YLogs. I'll paste the link in the chat as well if you're not following along in the notebook. I bet it'll be something like I'll just refresh later and it'll be there. That's the fun of doing stuff live. You know, something happens sometimes. All right, so any other questions real quick? I'll pause again just for a minute before we go into kind of the last portion of the notebook. There's still a lot of people here, which is really exciting. So hopefully you're enjoying this and learning something new. The last section, we're going to go in and use a little bit more of just YLog features. So we're going to look at using data drift or kind of calculating some data drift in your environment, and then also some data quality checks. So like we had mentioned, if you want to add a data quality check-in to make sure like you don't run a prediction with a model with that value of 33 in the flower length, then we can see how we do that here. So the cool part is like if you're already going to be using YLogs and YLabs to like monitor your data set over time, you can already use that library as well for things like data quality checks. All right, I'll keep going. As always, if you do have any questions about these things later, connect in the Slack channel. Link is in the description. So let's look at YLogs. Now we're just going to be using stuff directly in our Collab environment with YLogs here. So I'm going to go ahead and just create a whole bunch of profile views. That's where, if you remember, we created a profile view before where we took one of those data frames, we profiled it with YLogs. That's what we're doing here. And then we're able to inspect that like we saw before, where it had those summary statistics. Now we're going to look at a couple other features that you can do directly with YLogs. So one is detecting data drift with YLogs directly in your environment here. And here we're going to get a nice little visualization. So we can get kind of an idea of what our distribution of our data might look like here. And if you scroll over, or I have to scroll because I'm zoomed in. If you're not zoomed in, you probably don't have to scroll over. We have some other data around our profiles here. And again, these are broken up by columns, kind of like we've been seeing so far in like YLabs as well. So we can see that by default, YLogs uses the KS test algorithm for drift measurement. And you can set up a whole bunch of different drift ones. There's a link in here in a little bit, and I'll share it as well, where you can overwrite this and use different algorithms for different types of drift tests. So we can see that here our p-value from that is 0.994. The higher the number in this case, the closer the distribution is together. So there's no evidence of drift right now. And we can actually set up what this threshold is manually as well for evidence of drift. So right now it says possible drift if that value is 0.05. And no drift for these values. And we see the total count of rows as well. So we see that for all the columns. Looking at all these ones, all these numbers are changing, right? They're all a little bit different, but there's no evidence of drift detected. And if we want to drill down a little bit deeper, this one has possible drift detected, which is, class output. I forgot that we had built kind of a whole data frames with the class output and stuff in there. But let's drill down and look at a closer look into these feature values. So here we're just overlaying two profiles. I kind of skipped over it, maybe up here too. I guess I should walk through slower on the code. We imported the notebook profile visualizer from YLogs. We're creating a new visualization variable. And then we're passing in two profiles. So we pass in one profile and a second, and basically we're comparing those against each other. This is similar like when we saw in YLabs, we compared that 7 days of data. We were comparing each of those profiles to a single profile. In that case, it was a training data set. You could do something similar to that here, where you're profiling like a new day of data to a training data set or a previous day. And so that's where we're comparing, and that's how we're getting that KS number, basically. How different are those from each other? And if we drill down into some of the specific features, here in petal width, we can see the distribution is very similar to each other. A lot of the times they're overlaid. Same for petal length in this case. And let's do this again on, before we do it again, let's actually look at how we can get these raw values. So the visualizations are great, but if you want to pull those raw values of the p-values to make some sort of decision based on those, you can do that as well by using this calculate drift score function in YLogs. And this is where you can also overwrite kind of like what you consider no drift or possible drift. Let's look at another profile our 2 other profiles. We'll compare profile 3 now to profile 1. We'll look at our report here. And if we look, we can see that this has drift detected for sepal width. And I think that might be the only one for features in here where it says sepal width is drift detected. And again, we could kind of drill down. I got pedal width. Oops. Let's actually change one of these to sepal width. And we can see that it looks like there's a lot of overlay, but there's actually a little bit of a distribution shift. Like this reference profile has, I think, way more in the center is probably what's throwing off the KS test value there. And again, we can get the raw scores if we wanted to pull them in this kind of JSON dictionary format. And again, we're just kind of scratching the surface here. I just want to show some of the features. Depending on what your application is or how you're using it, you'll want to set up configuration for that application. And you can do a lot of different custom stuff, again, in YLogs. So there's an example where you can do like advanced configuration for drift algorithms directly in your environment. So now real quick, we've talked a couple times around data validation and being able to, detect if data doesn't fall where you expect it to be. Like we were saying, should we have 0 values? Maybe not. We definitely shouldn't have negative values for our iris measurements. And maybe that 33 was way too long that we had before, right? So how do we catch that? Someone said they really liked this visualization before when it was in the slides. It just kind of represents, right? Like null value, like that's not a good value you want. 42 is fine, 72 is fine. Maybe this negative value, that's not fine. We're going to set up kind of little unit tests for our data now. We're going to look at our YLogs profiles like we saw before and say, if the profile matches one of these things or it's greater than or less than this thing, throw some sort of error and we'll actually get a nice little report returned, as well as values that we can use in our pipeline. So here we're going to import some constraint helpers, and then I'll just run this, but I'll walk through what's going on here. So we're creating a function here to validate data. And in this case, we're going to be looking at 4 values. We want to look at the sepal length and width. And what we're going to get is, or what we're going to use are these add constraint functions to our constraint builder here that we're initializing. And we'll look at a profile and remind you exactly what it looks like. But basically, we had all those things in our profile where we're saying like, look at this column, pedal width, look at the distribution, and out of that, if the min on that distribution metrics is less than, make sure it's greater than 0 and less than 15 is what we were saying. So basically, anything in that profile, including custom metrics that you write in, you can set up some sort of validator like this. It's a little Lambda function. And we're just saying, make sure that the minimum value is over 0 and make sure that the maximum value is under 15. So this would catch any of those profiles that we had where there was that one that was 33 that I think we could clearly mark was probably wrong, and we had some that had 0 values, and this would catch all of those. So if we run this and we create this function, it's doing that same value check for all of our columns. And now we can run this validate feature. We're passing in profile 2, and then we'll see a better way of reading this, but you get this kind of tuple returned here that gives us the name that we put in, and then a value of 1 or 0. And this value of 1 means it passes. If the 1 was here, that means it fails, and it does that for each of those constraints that we created. But a much nicer way of visualizing that is this little report, which is really cool and interactive. Again, we only have 4 features here that we're checking, but you might have like 100 or something like that, or 100 different unit tests for all your features, and you can actually filter by failed, passed, look at them all. You can even search in here. So this is a cool way of visually checking, like, how's my data quality kind of pipeline doing that I created? How are these tests doing, maybe before I'm running these predictions on a machine learning model? And this is a really helpful feature is we can just call this validate method on there, and it'll return true if they all passed, and it'll return false if any of them failed. So this is what we would actually use probably if we wanted to run this before we ran our KNN model like we did before. We can just say, did these all pass? True? Yes. Great. Go make the prediction. If it failed, don't use that profile or that piece of data. So let's do this one more time on another profile. We can see this one passed, but we can see this one is triggered here, so that's a failure. And again, let's look at the visual. Way easier to read. We get this passed, one failed, passed. And if we call validate on it, look at that, false returned. And if we look at this profile, we can maybe understand why it failed. So this test that we wrote was the pedal width is greater than 0 and under 15. Let's go look at that min and max values for pedal width, which is this one. So max is 2.5, so it is under 15. So that's not why it's triggered. But the minimum is 0, and we're expecting the minimum to always be greater than 0 in this case. Yeah, someone said that seems correct. That's why it failed. Yes, it was supposed to fail, and I'm just showing why that's the case and how we wrote that little lambda function in our check. Basically, if you look at this profile, you can see what type of metric you have, distribution, and then we were looking at we added like a x.min and max, but you could add any of these other ones. And if you want to do types instead of distribution, you would have change that word out with types, and you could say fractional. For example, maybe we know we never want a string value to make a prediction for KNN. In this case, the way it's set up would definitely throw an error. So in this case, I mean, that is good that it would throw an error for us and probably nothing would move forward, but we might want to set unit tests for that as well and catch it earlier. So it's easy to set up, like, is it an object? Is it a string? Is it all fractional? Is the data basically what I'm expecting in the format that I'm expecting? You can do that here. Again, we're kind of touching on what you can do with YLogs and data validation. There's a lot more you can do. Go look at the GitHub repo. You have another thing called metric constraints where you can actually kind of do unit tests on your data even before it's profiled. So right now we're looking at those profiles, doing tests there, but you can also do tests like with a regex, essentially, making sure there's no email addresses or any PII in your data before you even profile. So we're going to wrap up with our content here in a second, but just a few other links that I'll share with people. One, if you want to get a certificate, you can request one here. It's just a quick Google form to fill out, and we'll make them. It'll probably be a few days before we send them out. And then we also do a lot of events. We have some upcoming events going on, sometimes in-person stuff as well as online. And I actually have specifically a couple really exciting ones coming up later in June. If you want to kind of learn more about our new project that we're launching called LangKit, which is going to be around monitoring large language models. There's going to be a workshop on that. It's going to be a little shorter. This one, I know we went through a lot of features. That one will be probably about an hour long. And then also I do a lot of events where I try to bring on interesting guests in the industry where we can ask them live questions. And we're going to be talking to someone about solving data hurdles, again, with large language models. I'm sure if you're in machine learning or in tech, LLMs are incredibly big right now and very interesting topic. So I'll be doing some neat events around that. Also, if you ever want to come on and tell us, your story and about interesting things you're working on, also feel free to send me a message and we can maybe get some sort of event, kind of like, I call them like a live podcast is kind of what we do. Also, there's a lot more to do in terms of learning. You can go check out the blog. There's a lot of resources there. And again, if you want to give us a star, you can do that on our GitHub, and that's kind of where the open source stuff lives, as well as a lot of other resources. And then emphasize really, again, if you want to join the Slack group, that's going to be a great place for you to ask any questions later. So if you are setting this up in your project or, just have any questions around ML monitoring or MLOps stuff in general, we're usually happy to answer them there. And it's a great way to stay connected with other people at the workshop. And with that, that's all the stuff that we kind of had planned to go through. So I'll stay on for a few minutes to go over any questions. And I'm surprised we're almost exactly at 2 hours. This is my first time running the whole 2-hour one. And so we're right on time, even though my explainability thing failed. I'm going to go look at that in a second and figure out why. And I'm sure when I find out, I'm going to be like, it was just something so simple that I messed up. Any questions though before we wrap up and everyone jumps off? Someone said, thank you. It was a great seminar. Thank you so much. Thank you so much for coming out. And letting me know it was good. It's always good for me to hear that. I know I can be pretty fast paced. Everyone has different style of content they enjoy consuming. I know when I go to something like a workshop, I kind of like drinking from the fire hose a little bit. And hopefully it wasn't too bad today. And hopefully you learned something new and we're able to follow along and you'll be able to, implement these concepts like ML monitoring in your pipeline. Someone said, so in terms of checking for bias and fairness, it can be a matter of creating custom constraints by understanding the data set and then including them within YLabs profiles. So the data constraints is a great way to kind of unit test your data before maybe you even send it to YLabs. I think that something important to think about is you can have a model in production. Maybe you don't even have those segments right now. But then you might think later like, oh, I need to know how my model's performing on this certain subgroup of my data set. So for example, ours was states. Maybe we had trained a model. We put it out. Maybe at first we weren't even thinking about, oh, we should be monitoring these different states. And then later on, we're like, oh, that's actually a segment that we should have in our data set and something we should include. And then so like going to the tracing, I think maybe you mentioned it in your wording, but thinking about how to segment your data and adding those to the profiles before you write them up to YLabs. That might have been what you're asking. And then you can use like that tracing tab to kind of drill down and find those interesting, maybe, they're not a huge error where you're going to catch maybe on data drift side or anything, but when you segment it, then you can start looking at them with performance or comparing performance and basically how they're doing across all those different segments. So thank you. Yeah, thank you again for coming, and hopefully I'll talk to some of you later in Slack or on LinkedIn or something like that. Someone said it was a lot of fun. And thank you for introducing the platform and explaining ML monitoring concepts. Awesome. Yeah, thank you so much for coming out. It was great having everyone. I think a lot of people might have come from AI Camp too. What a great community there. And yeah, I'm going to wrap up the stream here. And then I'll have to troubleshoot what I did for my explainability tab there. Again, if there are any other questions, join the Slack channel. Again, links to everything is in the description. Join that Slack channel and let me know, or let everyone in that Slack channel know any questions you have around ML monitoring specifically. But I'm going to go ahead and wrap up the stream. Thank you so much, everyone, for coming. Again, like I said, hopefully I'll talk to some of you all later.